Bem-vindos ao Type Theory for All podcast. This is your host, Pedro Abreu, and in this episode, we are going to talk with Dan Zheng, who has been doing PL for ML at Google since he was an intern and later he ended up being hired. Towards the end of this episode, we shift our attention to a subject that is very dear to both of our hearts, which is mental health. All right, so today we are here with a very special guest, a close friend of mine, Dan Zheng. Dan Zheng was also an undergrad here at Purdue, and he worked under Tjark Rumpf for quite a while. And nowadays, he is actually at Google doing some really cool projects. Thank you so much for accepting my invitation, Dan.
Yeah, thanks, Pedro. It's great to be here.
Dude, I am so envious of your voice. I wish I could have your voice. It would be such a better podcast if I had your voice. Maybe you should be the host today.
My voice changed in middle school. So in 6th or 7th grade, I started sounding like this. And back then, I fit my voice even less. I didn't look like somebody with this voice, but yeah, definitely still get comments on it. Appreciate it.
Hang on. So you're saying that when you're in 7th grade, how old is that? Like 13 or 14, and you had this full adult voice talking like a radio commenter. That must have been wild.
Yeah, a little younger, probably like 11 or 12 even.
Wow, that's impressive, man. It's pretty cool. So hey, tell us a little bit about your journey in PL. How did you get into PL? What's been your path in computer science? What do you like about it? How did you end up where you are?
Yeah, I guess I can start with my entire CS history since it's not too long.
Yeah, of course.
Yeah, so I started computer science in high school. Not super early like some other people, but my high school offered some computer science classes like Intro to CS using C++ and also AP Computer Science using Java, as well as some other classes like computer graphics and virtual reality.
Is that normal in high schools here to have like some intro to CS? Here in the US, I mean.
Yeah, I don't know how common it is, but definitely some percentage of high schools do have it.
That's amazing because in Brazil, we don't have that at all, It's not an option. I've never seen that. So that's really cool.
Yeah, it's sort of like foreign language classes, or probably the closest analogy is foreign language. Those exist in Brazil.
Yeah, everyone takes English for sure.
Yeah. So I was lucky to have a high school that offered these classes. And so, I took Intro to CS, learning C++ in the Borland C++ editor, and learned a lot of hacky stuff that didn't make sense. But it was quite interesting. And eventually I took AP Computer Science, with friends at high school. So when it came time to decide what major I wanted in college, this one kind of stood out to me. Some projects I remember from back then are hacking on some GUI-based games, like some card games, and staying up late to do this. So definitely had some interest there. Yeah, so from there, I went to Purdue University, majoring in CS, starting in 2015. And I started off only having a computer. So I did some web development because I didn't have a great phone. So I did some web apps, learning the JavaScript technologies at the time, like some Vue.js, tools like Jekyll for building static sites. And eventually I got interested in some machine learning, so more math-based things. And
just like everyone.
Yeah, just like everyone.
I feel in CS, everyone ends up being, like very interested in ML at some point, especially right now, right? It's so hot. It's good.
Definitely. I think as a younger student as well, I think, at least for myself, I was looking hard for opportunities. So any chance that somebody would pay me or give me a project, I would jump on it, even if it was terrible.
That's very interesting because actually, I don't know. I feel in the other hand, though, that ML is a little bit, how can I say, it's too many people. The market feels a little bit overcrowded in a sense, like all the smart people is already there. So at the same time that there is a lot of opportunity, sure. At the same time, I feel that it's extremely competitive for the same reason.
Yeah, I definitely feel that as well. I'm not an expert in the space, but I get that impression from conferences like NeurIPS, where the number of submitted papers increases every year. They have problems finding reviewers. The quality is variable, and the goals are maybe even a bit variable. Like what researchers sort of value and emphasize doesn't align with what matters in the real world potentially.
Yeah, I think I saw a professor on Twitter the other day saying that 80% of their applications were just for ML.
Oh,
Wow.
wow.
And like barely like something like 1% was for PL. And another 1% for like systems, like it's wild. It's crazy. Everyone
Yeah.
is wants the cool stuff of ML.
Yeah. Well, I heard that some students transfer. So, at Purdue University, as an example, PL is so cool that some people change from ML to PL.
Yeah, some people come to the cool side, huh? So you got interested in ML. That's when you got your first internship, I assume. How did that go?
Yeah, exactly. So, my first internship was during my sophomore year. I interned at a company called Digital Reasoning based in Nashville, Tennessee. This is back in 2017. Yeah, I applied to be a deep learning slash natural language processing intern. So yeah, that was definitely a great experience for me. I, went down to Nashville, and yeah, Nashville is a big medical city, lots of doctors, and also Vanderbilt University has like a good med school program. So my roommates were med students, a bit older than me, and there's great barbecue in the city. So actually,
I
right next to
heard.
where I,
I've
yeah,
heard.
right next to where I lived was a barbecue place. Not the best one, kind of smaller, but yeah, I would, commute to work every day. Um, but yeah, Nashville was a great experience. So what I did at Digital Reasoning was two things. I had two sort of intern hosts. So one of the projects was based on natural language processing, so machine learning for text. I learned about the cool techniques at the time, like word to vec and language models, which were pretty well, Word2Vec was a bit newer, and language models have been around. But yeah, learned about this technology and also the sort of libraries and frameworks at the time, things like PyTorch, older things like NLTK, and yeah, I worked on a data augmentation for text library. So, given a data set of text, like sentences or emails, how can you augment these texts, like perturb them in slight ways to get more entries in your data set? That was one thing. The other thing was some automatic speech recognition. So, learning to translate audio sort of speech into text, which is another pretty big problem in machine learning. And yeah, I played around with some different models of languages like Japanese. Is it better to use a character based model or a token based model for this transcription? And, some math things as well. There's something called CTC loss, which is a loss function used in ASR. So yeah, I feel really fortunate to have had the opportunity to learn about machine learning techniques.
That was just your first internship, right?
Yes, that's right. And yeah, at that time, I was also exploring PL a bit. So I met a great friend and mentor called Richard in my freshman year. We met at a hackathon for just a weekend, but we stayed in touch. And yeah, Richard is a few years older than me. So he had more classes, and he taught me things like Vim, basics of Lisp and Haskell, just what he was learning at the time, as well as eventually some machine learning and the Swift language, which he was a pretty big fan of. So yeah, during my internship, I was learning about Richard's undergraduate thesis project called DLVM, which was a machine learning compiler written in Swift. And so yeah, at that time, while I was writing all sorts of Python code for work, I sort of became a bit frustrated or dissatisfied with existing frameworks and wanted to become more of a compiler person to learn how to improve the state of the art there.
That's really cool. Yeah, I don't know. I feel that's a common theme for us that are on PL. Like we got kind of frustrated with the tools that we already have and start asking these questions, right? Of how can we make them better? Or what makes this actually bad in a sense? Like, it's not completely bad, but what is the underlying reason for things not working? So it's a good question.
Yeah, I think there's this trajectory of app developers or users of libraries wanting to extend the libraries. So they become library people. And maybe if you're crazy enough, you become a language person or a compiler person. Yeah.
Well, if you're not crazy enough, you'll definitely get there. You'll definitely get crazy enough.
Yeah.
But that's what you did. That's what you ended up being a library person. That's how would you say for you?
I may have skipped the library phase. Well, that's not true. I definitely had a library phase. But yeah, I think my interest quickly pivoted to compilers since that's what the LVM was. and also what I would be studying in school during my next semester back at Purdue with Tjerk Rumpf. I took his undergraduate compilers class, and actually from working with Richard, I had already learned about the technology called lightweight modular staging, LMS, which is one of the big ideas that Tjerk works with. So I think on the first day of class, I approached him and I was like, "Hey, I'm your fan. I've heard about LMS, and I read your paper. I'd love to learn more."
So then you started working with Dirk then?
Not immediately. I think I just took his class during the first semester, but after that semester, I was interested in some undergraduate research. So Tjerk had a research group that was not so many students, like maybe 5 to 7.
That's a lot. That's a lot for a study group in PL. It's pretty big enough.
Oh yeah, I think it's even bigger now, from what I understand. But yeah,
I've heard. Yes,
yeah,
I'm impressed. Derek can handle that many people. It's awesome.
yeah, it's definitely a really big management sort of role to have so many students.
So then, what did you research with him?
Yeah, I attended the weekly meetings, and I was rushed because I had a conflict. I had to leave within the first 30 minutes to go to a different class. But yeah, I basically worked on PL for machine learning, which is pretty related to the work that I had learned about from Richard previously. So yeah, that work with Tjerk's group is called Lantern. It's a deep learning framework using LMS that is written in Scala and combines a few sort of technologies like automatic differentiation, which is a necessary ingredient for deep learning. You need to be able to compute derivatives of functions in order to optimize them via gradient descent. And then some other cool PL things to implement that, like delimited continuations and also lightweight modular staging, staged programming to achieve performance. You can write idiomatic code in Scala that's very high level using deep learning layers and array APIs, but those get lowered efficiently down to C++ and CUDA.
Wow, you guys could publish that?
Yeah, it had actually already published by the time I joined the project. I think at conferences in 2018 maybe.
Wait, so you published stuff about Lantern before you joined Tjerk?
I was not the main author, certainly.
Oh,
That
right,
was,
right.
yeah, that was Fei Wang. Right. So this is something that I think mostly he drove, and then I joined as a undergraduate sort of helper, and yeah, I helped with the next paper, which was ICFP 2019.
Nice. Wow. I'm envious of you again, man, because I don't have a paper yet. I don't have a publication yet. Hopefully by the end of this semester.
Best of luck. Totally believe in you.
Thank you. But yeah, Faye is super smart. He was my TA when I was taking compilers. Which, by the way, that compilers class was one of the best class I've ever taken. Tiark he really make a good job teaching that class. I would recommend to anyone here at Purdue. Definitely recommend, especially because I don't know that Scala framework that they could pull off. It feels really clean. It feels like it was very well designed. Well, it was designed by Greg Sertel. Greg Sertel, he's like, oh my god, he is too good. He got. Do you know how many awards that guy got here at Purdue? He literally got all of the awards you can get during a PhD.
I didn't know that.
He has his name on there. There are plates of awards and names. He has his name there on the big awards twice. Like, come on, Greg, give us a chance, man. Yeah, but that's awesome. That's pretty cool. And where does Google comes into this display of yours, man? How did that happen? When?
Yeah, it's coming together. So I mentioned things for a reason. Google comes in via Richard. So
Oh,
Richard, yeah, Richard was a pretty big fan of Apple, and he knew about people like Chris Slatner growing up, I think, watching some talks. And so, Chris Slatner is the creator of LLVM and Clang and the Swift language. So at the time, Chris was a sort of director level person at Apple, and Richard got an internship at Apple working on Siri. And, Richard had already started his machine learning compiler project in Swift and wanted to sort of mention it to Chris and to others within Apple. And at the time, I heard that Chris wasn't so interested. He said, "I'm a compiler person. I don't know so much about machine learning." But Chris eventually, left Apple to go to Tesla, where he definitely worked on machine learning, and then to Google Brain, where he was in charge of TPUs, Google's tensor processing unit hardware, and TensorFlow. So yeah, Chris wanted to drive basically a new sort of compiler for TensorFlow and machine learning at Google. And so Richard was a obvious sort of candidate for that sort of team. So Chris reached out to Richard, who said, "Yeah, I can join, but I need an intern within my first month," and that was me. So I took a semester off to do an internship with the Swift for TensorFlow team. Yeah, that
That's
was
amazing. Wow.
that was January 2018 when I joined. The team was just starting, so I was one of the first members, like number 4 on the team, and yeah, it was definitely a very exciting time.
So what was this project in more detail?
Yeah, so the project is called Swift for TensorFlow. TensorFlow is the open source machine learning framework by Google that is pretty well known. Yeah, there are a few big frameworks in the space, namely TensorFlow and PyTorch. Also, JAX by Google is on the rise. But yeah, at the time, TensorFlow was certainly really big at Google, and still is. And so yeah, this Swift for TensorFlow project is intentionally called Swift for TensorFlow, not TensorFlow for Swift, because this is a new language and new platform for machine learning. It's not just language bindings like TensorFlow for, Java or Rust or something. So yeah, it's a new language for machine learning. And the biggest difference is that one of the biggest differences I would say is that Swift is a statically typed language. So you have more static safety. So, this influences how we design things. One of the first things I worked on was the array type called tensor. So you need a multi-dimensional array type because that is sort of the currency type to use in machine learning. Everything is sort of an array. Yeah, and then I worked on things like deep learning APIs, which are layers, machine learning layers, things like dense layers and convolutional layers. Yeah, and then things like machine learning optimizers. How do you update parameters of machine learning models so that they improve? But this is a very big project compared to some others within Google because the scope of it is huge. It's a new language for machine learning that involves, new core libraries like the array type, the deep learning libraries, but also changes to the language. So one of the things we did that's still ongoing is adding first-class differentiable programming to Swift. So automatic differentiation is integrated into language for the best usability, diagnostics, and performance. So, we're hacking the compiler as well.
Yeah, that's amazing. Is there any other language that? Oh, I think maybe Julia is that focused on ML, right? What else?
Yeah. About the Julia language, I heard, and I agree with this description, that Julia is like 2 languages. It is like Lisp in its sort of macro system, and it's also like Fortran in that it has arrays. So Julia is Lisp plus Fortran. I'm not a Julia person, so I could be totally wrong here. But yeah, I think Julia is a bit more domain specific, at least initially. I think right now the website says that they are general purpose. But yeah, I think Swift is even more general purpose in terms of its applications and like current usage, being used by many app developers around the world, as well as some new advancements in server side technology, people writing servers, and even cooler things. So yeah, I would say differentiable programming in Swift is not just limited to machine learning, but can be used for numerical computing in general, things like physics simulations or even finance, and even cooler things. Yeah.
That's really cool. Really cool stuff. Sounds like you need to optimize the language a lot for being able to do this differential programming well enough, right? Because I assume they have some really big arrays going on over there, so you really have to be smart of how how the language is doing those stuff. I can see why you would want those as a first language construct in your language. Makes a lot of sense.
Yeah, that's a great point. I'd say there are probably 2 considerations here. One is the language front end, the other is language backend. The front end involves things like programming language features and syntax. This is like what the user writes in their IDE. And you want to have good features here so that users can understand their code and have safe code. This is where static types come in handy. You can imagine if you have a language that is sufficiently powerful and has like dependent types, you can have sort of shape safety. So you can encode the shapes of arrays. So there are dimensions, which there may be multiple of. It can be like 2D or 3D or even higher dimensions. You want to know what they are at compile time. So You can avoid runtime errors due to shape mismatches. Things like that would be front end features. Also, differentiable programming is sort of a front end feature. It's designed to be general and not specific to just floats and arrays of floats. So
Hmm.
there's like a differentiable protocol. It's called a Swift protocol, which is like a interface or a type class. Make any of your types work with differentiation by implementing this protocol. And then, yeah, you mentioned optimizations. That's a huge backend consideration. So you want to have something that's fast and that can compile to accelerators like GPUs and other accelerators.
How does it change for you to think of a language so that you can optimize it for a GPU instead of a CPU? I assume there's a lot of differences here, right?
Yeah, there is a lot of differences for sure because the GPU is very specialized hardware. I'm definitely not a hardware expert, but I think what you want to run on the GPU is basically math operations on these arrays. And yeah, this is some pretty heavy duty compiler tech. And so another project at Google is called MLIR, not just at Google, it's part of the LLVM Foundation, totally open source. But yeah, MLIR is a multi-dimensional loop IR. And so you can encode these math programs in this IR, and there's progressive lowering and different dialects. So you can compile to various hardware, including GPU.
Oh, I see. So you compile down to LLVM and then, is that right?
Yeah, MLIR is actually more general than LLVM.
Oh,
So
okay. Sorry.
MLIR, yeah, no worries. MLIR is actually sort of a meta compiler framework. It's not itself a like specific compiler, but it enables multiple compilers to plug into the same IR within a single MLIR program. This is sort of addressing, from my perspective, I think when I started computer science, I and other students were wondering, like, why are there so many programming languages? Why can't we just have one, right?
The one programming language.
Exactly. Exactly. Or even just one IR. Maybe we can have multiple, front ends, but why can't we just have one universal IR that encompasses everying?
You know,
And the
I
reason,
didn't I
yeah,
didn't know about this MIR. Thank you for bringing to my attention. That's a really cool project, and I agree with you. It reminds me a lot of the WebAssembly too, so that you could theoretically program in any language and then deploy a website out of that. Not only because nowadays you can pretty much just use JavaScript or something based on JavaScript, say TypeScript, right? Maybe a little of PHP, but that's another topic. But it's basically it, right? So WebAssembly want to tackle that issue, and it seems to me that MIR is also tackling a similar issue here of, well, we have many different, when we are programming and when we are building a system, we are using many different languages. How can we bind them together? That's a big research question that is kind of going ongoing in our field right now. And a very important one too, because we have so many languages right now. Like we have so many people developing their own languages. And even more important than the language, it's the DSLs, which is like this very specific language for this one particular problem. How do we bind all of those things together, right? Very important.
yeah, just a bit more on this. I think MLIRs, yeah, definitely agree with WebAssembly. It's sort of LLVM like a universal sort of assembly language. I think MLIR's answer to multiple languages and their need to interoperate is letting them coexist, not forcing them to be unified, but letting
Yep.
them coexist.
Yep.
So MLIR has different dialects. You can plug in your own compiler, like LLVM or WebAssembly, some CUDA things, some new dialects like for linear algebra, and they can be optimized individually. They have their own parsing, type checking, verification, code generation, and so yeah, it allows different expert compilers to coexist.
Yeah, definitely. And also, you have to one thing that, as you said, the undergrads want this one language, but you fail to realize that you actually want different languages because each language will be more optimal to solve different problems. So the more high level, the more the language solve many different kinds of problems, the less you can optimize them, right? The less you can
Yeah,
optimize for different aspects. So you want a language just to do ML and do ML well and do ML fast, right? You want a language just to deal with arrays. Say you want a language to be more specialized for dealing with your browser. And you also want a language for systems. And in the end of the day, all those things, you want them to coexist well, right? Like you can never have this
yeah,
perfect language that will solve all of your problems. So yeah, very important, very good.
yeah. definitely. That reminds me a bit of going back to the PL world a bit more. Some language oriented programming from folks working in Racket. I think like Dr. Racket is a great IDE where you can have like a pound lang annotation, and you can have custom languages within Racket. One recent one I played with is the Pi language from the Little Typer.
Oh
That's
yeah.
really fun.
Oh
Yeah.
yeah, it is. It is. But well, yeah, Racket is still being designed for being a really good language for you to teach inside. So you need a good IDE to teach
Mhm.
that as well. And they've been doing a great job. Yeah, yeah. Dr. Racket is amazing. I wish I had more time to rack on Dr. Racket and Racket. You
Hmm.
can do some really really cool stuff. So for our listeners that never saw Dr. Racket happening, its IDE is the most responsive IDE out there to say, because for example you can hover your mouse over a variable, for example, and then it will draw a little arrow showing where that variable was first declared and where it's being used. And then you can actually write down very cool inference rules and actually have a very close to the paper implementation to what is going on. And not only the implementation is close to the paper, but the readability many times is also very close to the paper. So it's a really cool language that definitely is interesting to check it out if you haven't yet. I should check it out more, honestly.
Yeah. I think a key principle here is technology exists to serve users, and you should always have users in mind. So, yeah, Dr. Racket is great at that. These interactive environments like Jupyter Notebooks or Swift Playgrounds and Xcode,
hmm
I think are
hmm
other examples I really enjoyed. Yeah, using Swift and Xcode Playgrounds gave me a feel for the language with great code completion and instant feedback. So, yeah, there's a great talk by Brett Victor called Inventing on Principle, I believe, where he shows some IDE and some principles like creators need a connection to their creation. That's where things like instant feedback and hot module reloading can not only make you more productive, but they let you see things that you couldn't see before.
Yeah. Well, I mean, but you as a developer also realizes that sometimes getting there is very hard, right? Because when we are developing a software, it's kind of hard for us to step back and think like a user is going to think, right? And I think this is where the power of HCI comes in. Even for designing languages, right? Like you have to go out there, put the users to actually use and see how this tool, how this system is going to actually behave out there in the wild, how people is actually expecting it to use, where things are going to fail. And when they fail, how can we help the user to recover out of that fail? And I believe one project that is doing an excellent job in that as well is Rust. I was actually looking into why Rust is more popular than OCaml, because I started working with OCaml recently, and it seems to me that all the big problems that Rust is recently tackling has been already tackled by OCaml a long time ago, because OCaml is a much, I don't want to say much older language because I'm not sure of that. I have to double check, but I believe it's kind of the ML family is out there for a little longer, right? Like, and Rust is kind of very hot right now, solving this problem, saying like we're being the first ones to solve these problems, like kind of reference and all of that. But well, OCaml already tackled those problems, and it kind of works kind of well enough, I would say. And doing a little bit of research of why that happens, the big reason that I found is Rust has better interface. Rust is doing a big job into having good error messages, having very good documentation, which you really do not have in OCaml. OCaml documentation it's desirable. I mean, like it's something. Yeah. So yeah, this thing about putting yourself in the shoes of the user is very hard to get right. It's very easy to overlook, but it's extremely important.
Yeah, I think Rust is a great language in terms of a lot of different things, um, including the community and evolution process. But yeah, definitely also the attention to usability, things like the cargo package manager and cross compilation sort of just work.
Yeah, yeah, it just works, right? Like you compile and everything, boom, it fits together.
Yeah, it's like the technology is helping you, not you're fighting the technology and trying to learn all the different compiler hacks and flags and stuff.
Right, right. So, anyways, coming back a little bit, we were talking about how you got this amazing internship at Google thanks to your friend Richard, and then you're working on this cool PL for ML, Swift for TensorFlow, and you were happy. But then what? What happened when you came back and you still had to graduate? Did that happen? How'd that go?
Oh yeah, that definitely happened. I do have an undergraduate degree. Yeah, I think Purdue is pretty lenient about this. It's okay to take a semester off. I think other universities are probably also lenient. Yeah, I have a friend at
As long
University.
as you pay them, right? I mean,
Yeah, I think you don't need to pay them for your semester off because you're not taking classes and you're not paying
well,
for
I mean, so my point is they want to make sure that they're gonna make your life to come back easier, right? Because they still need your money in a sense. So, anyways, I'm just divaguing here. Go on.
Yeah, that's totally true. Yeah, so I came back after my internship for, that lasted 7 months. So basically the semester to finish my last semester. So yeah, I graduated in 3.5 years. I think Purdue's program doesn't require so many classes to be taken. I had some friends who graduated in 2.5 years even.
Oh,
You take a yeah, if you take a class, if you take a track like a computer science specialization that has even fewer requirements.
dude, I took almost 7 years to graduate in Brazil.
Oh, did you? How was that experience?
You make me feel dumb. Let's leave it there. No, I'm kidding because Brazil is a. I would consider we pretty much have get out of our undergrad with a master. It's one of the reasons why I really didn't want to make a master's here. Like we have to make a thesis by the end of our project. Our workload is a lot higher. We take a lot more classes.
Hmm.
I took calculus, I took physics, I took algebra, I took number theory, I took logic, I took compilers. I took a lot of courses that
Hmm.
you may or may not take usually here in the US, but for us in my university at least, and the universities that I know of in Brazil in general, it's more and a more comprehensive course. Like you want to learn many different areas of computer science so that then you can choose where you're gonna go for. Does that make sense?
Yeah, that makes sense.
Theoretically, you're supposed to graduate in 4 years and a half, but I know extremely very little number of people who could do that. Usually take 5.5, 6 usually. Compared to here, I took a long time, but compared to my friend, my actual peers, the norms.
Yeah. Do you think that knowledge has helped you? All of the sort of
Oh,
generalist classes like physics and these natural sciences.
that's a very good question, man. And for physics, absolutely not. I hate that I took all those classes. Like, why? Why did you do this to me? Well, I mean, if I was a game developer, knowing physics is important. That's what you're going to be doing. Like, not necessarily a game developer, but the guy who's actually working on the game engines, right? That's what you're doing. You're implementing physics for the computer. But that's not what I want. That's not what I'm going to do. That's a waste of my time. So in a sense, I feel that I wasted a lot of time that I could have applied to what I actually wanted and what I actually liked.
Hmm.
But on the other hand, it gives you the opportunity to explore things that you didn't even imagine that you would enjoy. So, for example, if I never have taken the number theory class, I would never know how much I love doing proofs. Does that make
Yeah,
sense?
totally.
And number theory is not a course that you're gonna see an undergrad extremely excited to. So it's good
Yeah.
in that sense, right? But there are other courses that you just despise and you just have to get through of it. So for example, another thing that I had to do is calculus 1, 2, and 3. Why on earth do I need to learn how to calculate the volume of the sphere with triple integrals? I'm never using that in my life. I hope like that's not something I want to work with. Like
Hmm.
those are sort of knowledge that I literally kind of erase off my mind.
Yeah.
But at the same time, I don't know. I I have mixed feelings about it.
Yeah.
I think in Brazil it could be a little more objective with our curriculum. I think, and Another thing for that to happen is because of the in Brazil our education is free, so
Hmm.
I feel a little less of a rush in the students to complete their program as well. That's good and that's bad at the same time. So it's good because I feel here people is extremely stressed. Like it's very easy for you to burn out. Like you're gonna work crazy times and students
Hmm.
get very hard. But it's good to be more chilled like that because then you can take your time and really absorb those things. Here at the same time I feel students are just memorizing, not actually
Hmm.
learning. But on the other hand, it also creates this environment in Brazil where people don't care that much. It's very common for people to drop out the course, so the evasion rate ratio is huge, which is basically not only throwing away their time as people of their lives, like it's also throwing away public money. So
Yeah.
it's a trade-off. I think both cultures have a lot to learn from each other, I would say. And I've been learning a lot here in the US, that's for sure.
Yeah. Yeah. I definitely relate to a lot of what you said as someone who's Chinese. Even though I was born here in the United States, I studied a bit before in China in elementary school, middle school during summers, just for a month. After school ended here in the US, I would go back to China and study there for a month as well until they had their final exams. I think that's
Wow. Like, were they teaching the same things or they were kind of unrelated and you had to catch up every time that you made the transition?
Yeah, my parents really valued my education. My dad is a college professor of Japanese, actually. So even though we're Chinese, he teaches Japanese. But yeah, I'm very thankful to my parents for giving me that experience. Definitely, the material is all different, right? It's all in
Oh,
Chinese. The math is more advanced than in the U.S. for like the same grade for sure. So
what do you mean by more advanced?
education in general in China is more rigorous. Students have way more homework. Many things are different. They study much longer hours. The textbooks are smaller, but way more like condensed, and students like memorize it front to back. Instead of in the US, you have these giant textbooks that you sort of skim. Yeah, for me, it was a taste of having a really rigorous education. In the US, I needed to study, the same textbooks that the Chinese students were throughout the school year so that I could like be on pace. I would have studied all of the Chinese sort of chapters that they had studied, and I could, do okay on tests every time I went back to school. So I did this from first grade all the way, second grade here, second grade for me all the way until like eighth grade. So that's quite
Wow.
a few summers. And yeah, I would start, and the first week I arrived, I would do like a 60 or something on the Chinese essay, or the Chinese test, including an essay. But yeah, as time passed, like week 2, week 3, I'd be doing like better on math, like closer to 80s, 90s, maybe like 70s, 80s on the Chinese. But yeah, I can definitely relate to your experience in Brazil. Sounds like it's also more rigorous in Brazil, maybe more of a focused on testing. Is that true?
Not. I'm not sure. Not really. Like it's the testing side is kind of similar to here,
Hmm.
but yeah, it's not. It's not that bad on testing side. Like I feel that professors put a little more effort into understanding if you understand the material than here. Here, the professors are just worried if you get the question right or wrong.
Hmm.
Yes or no, kind of thing. There is a little more lenient in this side of like trying to build this sort of relationship between professor and students, like a more humane process in the sense of
Yeah.
like the professor has a closer proximity to the student to assess whether he learned enough or not. So it's more lenient in that side. We're more lenient and more put more human aspect into education. Does that make sense?
Yeah, that makes a lot of sense and sounds like a much better system than
Yeah, it
test scores.
in a sense it got me very frustrated here in the US when I found how things are very impersonal. Don't take people into account. You're a number here, you know. But you're talking about how the Chinese is extremely rigorous. Actually explains a lot because I've had a lot of Chinese colleagues like taking the same course as I have, And I always feel so dumb near near Chinese. Like people, Chinese are so smart. They always take the average grade so up high, and I'm like, how am I supposed to compete with this? I can't do this. So I actually failed networks here at Purdue, graduate networks twice, and I feel that was the main reason because there were too many Chinese, and I couldn't
Yeah.
compete. It was tough. It was tough. You guys are awesome. So
Yeah.
coming back again to your graduation. So you graduated and you were actually hired by Google. Is that right?
Yeah, that's right. I joined the social team full time.
So you're there since 2019.
Yep, exactly. Basically, exactly a year after my internship started. I started full time.
Wow. So I have two questions for you here. The first one is like, how hard? Well, I think for you it was not okay. So here's what is my mind. A lot of people who want to get into Google, they spend a lot of time studying for code interviews. You gotta take that book. What's the name of that big important book for code
Cracking the coding
interview? Hacking the code interview. Thank you. The Bible of the guy who's just about to graduate, right, in CS. They're gonna learn that book back to back, and then they're gonna go to the code interview and try to get all those three questions correctly. How was this experience to you? Do you think it was hard? Do you think it was not that hard? And the second question is related to how would you compare your transition work, like from undergrad to working in the industry? How did you feel about that?
Yeah. So two questions. The first is about the conversion process or the full-time job application process, and the second is about the specifics of the transition, I think.
Yeah.
So yeah, the first question about the interview process. For me, it was relatively smooth, for which I'm thankful because I was an intern previously, and there's a intern conversion process at Google. So it's a bit easier for previous interns to become full-time if they want to. I think probably every company has something like this because
Hmm. Hmm.
part of the reason why you have internships is that you want them to sort of stay with the company. So you invest resources in them and they stay.
It's a much safer bet. Let's put it that way, right? Like you have a better opportunity to assess if the person would fit there or not, other than just getting him there to solve a bunch of questions and like you just meet him for a couple of hours, right? So internships are great for that. Yeah.
Yeah, totally. I definitely cannot speak on behalf of Google, the company. So I can give some of my personal thoughts here. I think, yeah, it is probably necessary and good to do some general coding question practice before a technical interview. So this is like, I think, pretty standard among tech companies. Yeah, it just establishes some baseline competency. And at Google, I think there's a pretty good system. So things are very fair. Yeah. At the same time, sometimes it's good to hire for special roles. If, somebody is an expert, maybe they're a PhD or postdoc in the field, you know, it's sort of you could imagine it doesn't matter so much how they do on like a general purpose coding interview about how do you traverse a tree. What matters is their domain expertise, how now you sort of know the person. So yeah, I think there are these two things. I think some people are kind of against general coding interviews because they feel they have sort of a track record in the industry. Like just go see my GitHub and go see my open source code, go see my tweets, go see my papers. But yeah, for me personally, I still feel pretty young and I don't mind doing those coding interviews so much. So yeah, I think one thing though about the interview process, I would say is what matters the most is like your interactions with the team after you join. Google and other companies are very big and certainly not homogenous in terms of culture and the nature of the work, many dimensions. So what matters the most is like getting to know the team really and knowing the manager, knowing like how's their communication style, how do they work together, is there a lot of collaboration, stuff like that matters the most. And so yeah, I heard about some interesting interview practices where they don't ask you like a traditional like algorithms or data structure question. They just ask you to like start pure coding. Like, hey, can you start writing like a web server? And then you can see people's like development process. Or sometimes even they give the person a sort of work related task. Like, hey, can you solve this like hobby project in like a week or something? And so, yeah, I think those things are much more indicative of what it's like to work with a person in the same sense that, tests are maybe not the greatest indication of whether somebody knows something. what you really care about is how they internalized it and like some
Yep.
of the humanist aspects. Yeah. So those are some unorganized thoughts about the interview process. About my transition personally, um, yeah, it was pretty tough for me at the time. That's because I was in a state of having constant transitions in life. Starting in high school, things are lasting for just a while. You know, things may be tough, maybe your classes are hard, but soon I'll graduate and I can sprint towards that deadline. Same with my studying in China, even as a kid, from elementary school up until middle school. Wow, I got to get up at 5:30 a.m. to finish writing this Chinese essay. That kind of sucks, especially when it's so hot during the summer. But there's an end. There's an end. It's just 1 month. I'm going to go back to my, American life and leave behind all these Chinese family and friends. So yeah, same in college. College is like there's a semester. No matter how hard this class is, I just got to cram and study until I pass.
And
Yeah.
then summer will
Also,
come and you can just chill and relax and have this amazing 3 months and go to the pool, yeah.
yeah, hopefully, or you feel lots of FOMO, like fear of missing out from your friends doing really cool internships and stuff. So yeah, good to not compare yourself too much with other people. But for me, it was really hard. During my internship, I worked really hard. It was 7 months long. So yeah, I wasn't really mentally even ready for full time necessarily. I just
Hmm.
finished a graduate level class with TRC, which is like deep learning and symbolic reasoning. That was really cool, but also due to my personal reasons, I got kind of stressed out on that. So I didn't take so much downtime to recover and just launched into work. So yeah, at work, I continued sort of the internship lifestyle where I was working very hard, basically like a college student, very
Yeah.
long work weeks, staying late at the office. So yeah, that definitely led to some eventual burnout. But yeah, I learned a lot of things along the way, working with such brilliant people in a sort of well-known institution.
I can relate a lot to that because yeah, I feel I had a similar experience in this my last internship. But I don't know, I feel like this idea of finishing your studies and actually going to work is something that we are not taught. It's impossible to teach that. So
Mm.
it's okay. It's normal and it's okay to feel this difference really early on. Also, you're super young. How old are you? You're 19, 20
I was 19 and 20. I just turned
back then,
23.
right? Yeah, yeah. Like you graduated extremely young, right? Like, and then you're putting all these expectations in the shoulder of this extremely young person, and it's a little too much, right? But yeah, I definitely feel you that in school it's okay, like when you're in college, when you're in school, it's okay for us to work long hours because this is gonna end, right? Like this have a
Hmm.
limited time frame to work, and then will come a time where things will change and we can kind of reset, right? But we don't realize that this is not gonna happen out there in our jobs in the industry in the wild. So it seems to me very logical that we end up making this dumb decision of working too much, like. And I don't know, there's also the case that we are new to the workplace, we are new there, we want to prove ourselves, we want to prove that we know we don't necessarily know what we're doing because most of the times we don't, but that's normal too. But we
Yeah.
want to show that we are capable, that no matter what they throw at us, we're going to be able to do it. And one thing they don't tell us about work is that every time that you're never going to finish, you're not going to be over with. Every time that you finish something, the next problem will come, and will come right away. So if you don't pace yourself, you will burn out. We'll have problems. So it's more important for us to find our the right pace for us to go through. But yeah, I definitely say that I can relate to this because I also kind of burned out this last semester. I was in this internship working all day in my room. I also already mentioned this on the last episode, but the key idea here is that I didn't pace myself. I just kept working and working and working and working a lot, and in the end, it was a lot more than I was able to handle for a lot longer than I was able to handle. Right,
Mm.
and this actually this actually brings me to a topic that I wanted to touch last episode, but I think I ended up forgetting actually. It was our other topics were just so fun that I I'm happy that we have the chance to touch it again this episode, which is mental health, right? Especially both
Mm.
in industry and in academia. It's extremely important to take care of our mental health, and there is no shame there. We have to create this, we have to talk more about this, I feel, to create an environment where mental health is more valued from people to people, because I was actually looking into some numbers, and more than 50% of grad students go through depression. That's an like that's
Yeah.
a wild number. Like, there's a problem here, guys. We have to talk about this. We have to somehow create an environment such that we can address this problem and we can make this smaller, right? And definitely one of the reasons it happens is working too much. Another reason is sometimes you feel socially isolated here. At least here on academia and grad school, sometimes you get so hyper focused working on your own project that you lose sense of everything else that is going around you. You lose sense of that there are other people around you, right? And in grad school you just feel so dumb all the time that you lose sense of how smart you actually are too, right? Which is
Yeah.
one of the reasons why I love TAing, because it brings this fresh sense of that you know a thing or another too. But how do you feel about it on industry? Like, what do you think are the biggest factors for having trouble with mental health?
Yeah. Thanks, Pedro, for bringing up this topic. I think it's very important and something I have personal experience with as well. I think it's not just a academia versus industry issue in PL or computer science. It's a human thing. It's a universal experience where people feel stressed out, especially during current times where we have, COVID going on. There's lots of social isolation. People feel kind of lonely and distanced, and there's less, human interactions. So yeah, I think in industry, I definitely got burned out. So, and I got burned out pretty recently, actually. Yeah, after COVID started, I moved apartments and was in a studio apartment with someone. We're both software engineers, having multiple meetings per day. And yeah, just living in that space together for a long time is really tough. It's something that I didn't realize. And over time, I got too stressed out from trying to take on work things in addition to life things like cleaning and cooking. So yeah, I actually had to take a mental health leave from work. That was very scary for me. I'd never taken a leave before. I had studied AP psychology before in high school. It's actually the most influential class I've taken, even in college. I had a great teacher in high school. So I knew about psychology, both the hard science, like neuroscience and biology parts that it wants to be. Like you have depression and it's because of this thing in your brain, and we can, pinpoint it, but also very soft things like what is happiness, what is the meaning of life, what is learning. So yeah, I had some experience with mental health. I didn't view it as a stigma, but at the same time, I was severely depressed. I couldn't get out of bed. I was having trouble communicating. Like I couldn't talk and write fluently. I, yeah, probably had some depression and anxiety, and it got pretty severe to the point where I had to ask help from my family to help me initiate a disability leave and take time off from work to recover. Yeah, that has been super good. So it's been a few months since then. I definitely have recovered in a big way. So I think one funny analogy I heard from the Armchair Expert podcast by Dax Shepard is great podcast, by the way. But yeah, he talks about this analogy. So I can share this with you, Pedro. Um, since you recently bought a car, I believe. So
Yeah,
congratulations.
thank you.
So God forbid, let's say your car breaks down and you got to get to school. Um, and it's a really, or, you have some travel to do to a different state. It's super important, right? So who do you trust to fix your car? Yourself, or are you going to call a mechanic?
Oh, I'm calling the mechanic all the way, for sure.
For sure. Why do you call the mechanic?
He knows what he's doing, right?
He knows what he's doing. Exactly. So if you care about your car that much, what about your mental health? You
Hmm.
should be seeking professional help for your mental health as well, which can look like therapy or doctors. Um, so yeah, really, take yourself, treat it like a medical issue, because I think disability And mental health issues really are sort of the leading cause of disability and loss of productivity in the world. For me, I felt like I didn't have free will anymore when I couldn't talk or write.
Oh, yeah. This is such a powerful story because we think like that for like physical possessions like a car, right? But when we're talking about ourselves, about our own body and our own mind, that's so much more valuable than our car, right? And we don't realize that until we have problems. So putting it in the right perspective, just as you just put, thank you so much for bringing this in. I love it. I love it. Like just putting in put it put your mental health into perspective of how important it is because it's just the foundation of everything else. Without the mental health, you
Yeah.
cannot work, you cannot be productive, you're not gonna function, right? Like look at what happened to you. You will not be able to get out of bed. So this is actually kind of a promise that I did to myself and my therapist. But by the way, I had to go through like to win this mental stigma in my head of finding a therapist. Which, by the way, I recommend everyone to do because nobody's 100% healthy, right? Like therapy is just so valuable in so many different ways because exactly as you said, they know what they're doing. And when I'm talking with my therapist, it feels like she understands my mind in ways that I don't, right? Like she knows how to get around those things and what is she can see much better what are the sources, the actual sources of the problems, which I have no clue. And she really helps me to navigate through that mess that is thoughts, right? And it took a lot for me to win to get over this stigma of finding professional health, right? Professional help, because I thought in a way I was raised in a way that it's kind of it's shameful or it's kind of for crazy people, right? But that's not the case at all. We all have problems in some scale. And I did this promise to myself actually when I first started grad school that I would put mental health as the absolute priority in my life, exactly because what you said,
Yeah.
that you do not function without mental health. Mental health is the base for everything else, right? And okay, so we know that mental health now is super important, but how can we make sure that we remain mental healthy? What are your thoughts?
Yeah. First of all, thanks for sharing your experience and all the positive ideas that you mentioned. I think those are really great, and I'm really happy for you. I think, yeah, I can share some of my learnings during this time. Maybe they can apply or help to other people as well. I think so. Some things I've noticed and learned about are cognitive distortions. This is something that you might talk about with your therapist, or a therapist might tell you about. Basically, these are like fake realities. I had a lot of these when I was very depressed. I had these feelings that weren't grounded in reality. They were just totally false, but they applied a lot of pressure to me. Things like I can't talk, I can't write well, I can't cook. And when it becomes a negative feedback loop like that, it really interferes with everything else in your life because it takes up non-negligible brain space. I felt so overstimulated by negative thoughts that I couldn't do anything else. As soon as I got out of bed, it was just, negativity. And so, yeah, it takes a lot of self compassion and talking to a third party, just someone who's not yourself, like a good friend or a family member to say, this is totally untrue. Like, this is not even a real thought. It's not representative of reality. And so, recognizing those things is pretty important. Other things are like black or white thinking. Either I run like a half marathon or I'm a failure, or either I finish this project tonight and finish this paper tonight, or I failed. But that's not true either. You have to give yourself credit for the incremental progress you make and to really value that. So there are a lot of mindset changes here. One more is about rumination, which is just worrying about things like, oh my gosh, this paper deadline's coming up, and my idea is totally bad, and I feel ashamed to talk to my advisor, as an example. Just thinking about that continually doesn't help you at all. It probably sends you into a spiral of anxiety. And so, really recognize when you're doing this unproductive negative feedback loop. And instead, you can try to do things like problem solving. So, productive thoughts that work towards a solution, breaking things down into steps, or even if it's something out of your control, like, hey, I might be fired, or, something that's external to us that's going on. You can recognize that we have no control over it. And so there's no reason to feel bad about it. You can distract yourself or try to take care of yourself instead. One last thing is maybe mood. During when I felt extremely bad, I had really low mood all the time, even though other people can see. So, yeah, mental health is really hard to see because it's basically diseased thoughts. You have thoughts that are not good, that aren't grounded in reality. And so it's really hard for a layperson to analyze these things. You really need a professional doctor. And for me, my current mood colors my experience of the world a lot. When I'm feeling good, I think back on memories and like everything seems kind of good. Like, oh yeah, I can see why that happened. I'm thankful and whatnot. But when I'm feeling bad, everything also has sort of a negative tint potentially. So another example of mood and like temporary thoughts is procrastination. Like, oh man, I do not want to finish this homework assignment. It's so boring. I just need these credits to pass to graduate. But you can recognize that these are sort of fleeting thoughts that don't really matter. And they might, go away by themselves over time. Another one is like wanting to eat snacks or something. And so, yeah, you can realize that you don't have to obey your thoughts. I can
Oh,
dislike this class, but still do the homework. I can not want to get out of bed, but I can still put on my shoes and go for a jog. And also that mood has inertia. It's really heavy. Like it's really hard to change just because I know something logically makes sense. Like, this project really is hard. I should be more kind to myself. Or, hey, even though I feel so bad and I'm really spoiled, I should be more thankful for all the good things that are happening to me. Don't expect immediate progress. These things take a lot of time. So be self compassionate and, yeah, don't try to see immediate results too much. Don't invest too much in seeing that. It really takes a very open and compassionate mindset for yourself. You have
oh
to really
yeah.
love yourself first.
It's very hard to learn how to love yourself. That's very true. Very true. Actually, this thing you were talking about, how the thoughts really influence you. Like another thing that is very hard for us to realize at times is that I am not my thoughts necessarily. There are some thoughts that come that are just hurtful, and that does not mean that that's you. Like just because sometime it pops up in your mind that you're a failure, don't mean you're a failure, don't mean you actually think you're a failure. Like thoughts are tricky, right? Like thoughts come and go, thoughts are very ethereal. And one thing that helped me a lot in that sense of like getting a better grasp and a better hold of my mind is meditation. So I could find a good meditation routine now that helps me tremendously. I don't know how I survived before having a good meditation routine. Like it just puts things back into perspective, center myself back into the right place, and organize my thoughts in a way. Like because when I meditate, I feel that there's less pressure in my head of things just aimlessly going on. Like really creates this perspective. And another thing that for me is extremely important is to take care of my physical health. Takes a big hit into taking care of my mental health. So making physical activities 3 times a week, like 1 hour each time, that is huge, not only for your mental health but your overall health, right? So I make sure to go to the gym 3 times a week, 1 or 1 hour and a half each day. We are golden. Like that's huge priority. That's first thing for me, because again, health for me is a huge priority. But man, you gave so much amazing insight, so much perspective. I am so glad that we could have this conversation about mental health. It was amazing. Do you want to bring up something else that we didn't have a chance to talk about? Maybe some advice for people, some advice for someone who's looking for an internship at Google. I don't know. The mic is yours, man.
Yeah. Thanks for putting me on the spot. I think, yeah, I can talk about one thing I've learned. One of many things I've learned in the last few years is about decision making. So we all make lots of decisions every day. Some of them are big, some are small. I think having a clear mission about what you want to do can give you the answer to many other questions in your life. You need some sort of principles or focus.
What do you mean? What do you mean more exactly? What do you want to do? In what sense? Like in general, from your life? What do you want to be from your life? Something like that?
Yeah, I didn't think through this very carefully, but I think I can explain it. So this also has to do with like rumination versus problem solving.
Mm-hmm.
Um, I would say don't ruminate too much on things if it's not productive. Instead, try to make a list of pros and cons if you have a hard decision. And once you make the decision, everything else in life becomes easy. It becomes very apparent what you should do. It's just execution. So you need to decide, do I want to go to grad school or not? List the pros and cons and your life trajectory after that. And yeah, once you make up your mind, then it's very easy to do other things like find the apartment at the university, um, sign up for classes. You have to take the time to, think about those things. And yeah, it's sort of a creative process. It's definitely requires a lot of cognitive sort of function. So if you don't have that, if you're very depressed, it's hard to do these things. But yeah, I'd say when you have a clear mission as an individual or a group or a company, then everything else becomes kind of easy. Like
Everything falls apart from that. Yeah, yeah.
technology is not hard. Like problems are not so hard. The hard thing is humans in the decision making.
That is so true. That is so true. Man, thank you so much for your time here. Oh, sorry, did I interrupt you?
Oh, not at all.
Uh,
I just had a yawn and a laugh. So yeah, definitely really happy to be here, Pedro. Thanks for having me. And I hope to see you again someday pretty
No,
soon.
yeah, of course. Thank you so much for coming. We had an amazing conversation. We really touched some very important points. We had a little understanding of the work, some PL and ML work going at Google. It was a great chat. Thank you so much, man.
Thanks, Pedro.
This concludes our third episode of this show. You can find Dan at Twitter at Dan Sherp with a CH. That's DANCHERP. If you like this episode, make sure to share it with a friend that you think that would enjoy this episode. That's the best way to help us grow and to keep producing more episodes. If you have comments or questions, please leave them at the website www.typetheoryforall.com. And I hope to see you next time.